We're now going to continue our discussion of 6.5 and look at some problems and examples utilizing the inverse trigonometric functions. Let's begin with a quick review of the definitions of these functions, how they're defined on the graph, and which quadrants they're going to pull from. So in our chart from our last presentation, you can see that we have the 6 inverse trig functions. We have the restriction on the domain for each one, and we have the corresponding quadrants that we will be using as we work problems. You also want to be familiar with your table of exact values that we looked at several sections ago. So either take a minute and pause the presentation and write this down, or print it out so that you have this to reference as we begin working problems. So let's begin by looking at what a problem typically looks like when we're being asked to find a value for a specific trig function. For example, a question that we might be asked would be a question like this. And this question is asking me for the sine value at pi over 6. And so what I want you to keep in mind, we know that the answer to this would be 1/2. We know that sine at pi over 6 is equal to 1/2. And we can get that from our memory or also from our chart. Okay, here's your pi over 6 angle. We're looking at the sine value, so we're at 1/2. So what I want you to keep in mind here is that a typical trig problem has 3 parts. Okay, we have the function. We have the angle. And we have the value. Now, when our problem changes to an inverse trig function, what happens to these 3 parts is that they mix up. And instead of looking for the value, we are looking for the angle. So a normal trigonometric inverse problem might look something like this. Okay, so they're still going to give me the function. They're going to give me the value. And the question mark is going to be the angle. It's going to be the missing piece. And so our answer here would be the pi over 6, and that would be our angle. So you want to keep in mind that when you have an inverse trig function, like inverse sine or inverse cosine, we are looking for an angle. And this is so important because students get confused here, because the original problems that we worked in, we're looking for the value. When we switch to the inverse, we're now looking for the angle. Okay, so that's an explanation of what we're going to be doing. We're going to be looking for the angles that go with the given trig function and the given trig value. Now, remember that each of these trig functions has a restriction on the domain and a corresponding quadrant. What this tells me is that when I give my answer for the angle, if I'm working with a sine, the angle that I give has to be in one of these 2 quadrants. So on my sine inverse, I've got to use either quadrant 1 or quadrant 4. Now, it's a reasonable question to ask, why did they give me 2 quadrants? The reason that they gave you 2 quadrants is that one quadrant is going to produce all of the positive angles. Those will be in quadrant 1, or the positive values, and for the negative values, we will be using quadrant 4. So since in our original problem here the 1/2 was positive, then our angle should be in quadrant 1. Okay, so let's look at some other examples, and what we want to do here is we want to run through as many examples as possible so that you get a feel for how these problems work. All right, so I'm going to do several for each of my trig values. All right, so let's say that we have sine inverse of square root of 3 over 2. Let's say we have sine inverse of square root of 2 over 2. And let's say we have sine inverse of negative 1/2. Now, if you want, you can pause the presentation here and work on these and see if you can figure out the angles that go with each of these values for the sine functions. All right, we're keeping in mind the positive or the negative on the value. So the first one is square root of 3 over 2. It is positive, so we should be giving an answer that is in quadrant 1. The square root of 2 over 2 is positive, so we should again be given an answer in quadrant 1. The 1/2 is negative, which means that the angle that we give should be in quadrant 4. Okay, so let's find that angle. So I'm going to flip back to my chart for a second. For the first one, I'm looking for the angle where sine is equal to square root of 3 over 2. I see that here. The angle is pi over 3. Our next one asks me to find the angle where sine is equal to square root of 2 over 2. So I look in my sine column for square root of 2 over 2. Now realize that that is a value here that has been not rationalized. So if I rationalize this value, multiplying top and bottom by square root of 2, I get that square root of 2 over 2 that I was looking for. And so my angle is going to be pi over 4. Again, both of those angles are in quadrant 1. Now, for the third problem, we have the 1/2, but it is negative, so we need to be in quadrant 4. The easiest approach to use is to pretend for a second that the negative is not there. Go to your chart and find the angle where sine is equal to 1/2. So sine is equal to 1/2 right here. And the angle that goes with it is pi over 6. So what we know is that sine pi over 6 is equal to positive 1/2. Okay, I need to take that angle and now move it into the fourth quadrant. So the easiest way to move that angle into the fourth quadrant, keep in mind pi over 6 is here. That's a positive pi over 6. So if we need that angle to be in quadrant 4, we're simply going to rotate down instead of up. And so my angle is going to be negative pi over 6. Okay, so let me sum that up for you. So if we need to be in quadrant 4, we can find our quadrant 1 angle first, and then simply put a negative on it, indicating that we're going to rotate down into quadrant 4 instead of up into quadrant 1. Okay, let me give you one more of the sine ones. Let's say that we have sine inverse of positive 1. So I need an angle where the sine graph, or where the sine function is equal to positive 1. So if I go back to my chart, I'm looking for a place where sine is equal to 1. I see that that happens at pi over 2. And pi over 2 is not exactly in quadrant 1 or in quadrant 4, but remember that our restriction allows that because it has the bracket on those values. So those are included even though they lie on the x and y axis. Okay, so let's move on and let's do a few tangent ones. Now the reason that I'm moving to tangent next is because remember that tangent and sine share the same restriction and the same quadrants. So let's just do a few of those to be sure that we're okay with that. Okay, so let's say that we have tangent inverse of negative square root of 3. And we have tangent inverse of positive 1. We'll just do a couple here. Okay, again, the first one has a negative value, meaning that we need to be in quadrant 4. The second one has a positive value of 1, which means that our angle should lie in quadrant 1. So our restrictions and quadrants are exactly the same as what we did for the sine function. Okay, so let's go find these values. I need a place where tangent is equal to square root of 3. Remember that initially we're going to ignore the negative. So let's go to our chart. We want a place where tangent is equal to square root of 3. That's going to be here. The angle is going to be pi over 3. Now remember that pi over 3 is a quadrant 1 angle. It's an angle that has been rotated up. We need our angle to be in quadrant 4, so remember we're going to rotate it down, causing the negative to go on the angle to show a downward rotation into quadrant 4. All right, our next one says tangent inverse of 1. So again, back to our chart, let's find the place where tangent's equal to 1. Here we go, right here, and the angle is pi over 4. 1 is positive, and so our angle should lie in the first quadrant, which pi over 4 does do that. Okay, the other one with the same restriction would be a cosecant problem. Okay, cosecant also runs in quadrant 1 and quadrant 4. So let's do a couple of those. So let's say that we're looking at cosecant inverse of 2. And let's say that we're looking at cosecant inverse of square root of 2, and let's make this one negative. All right, so again, if the value is positive, like on the 2, we know that we want our answer to come from quadrant 1. If our value is negative, we want our answer to come from quadrant 4. All right, so how do we deal with a cosecant when we have a chart that only has sine, cosine, and tangent? So we're going to have to treat these cosecants as a reciprocal sine function. So if cosecant is going to equal 2, then what this means is that the sine will equal 1/2. Remember that sine and cosecant are reciprocals, and 2 and 1/2 are reciprocals. So we're looking for a place where sine is equal to positive 1/2 in our chart. And so here we go, and the corresponding angle is pi over 6. All right, similarly, we're going to do the same thing for the second one. Our cosecant value is negative square root of 2, so let's get our sine value. So the sine would be the reciprocal of that. Right now this sits over 1, and so we'll turn it over. And that might be enough. We could rationalize it if we want, but having it 1 over the square root of 2 is more than likely going to match something in our table. So let's go look. All right, so 1 over the square root of 2 is here for the sine. The angle is pi over 4. Now, how do we account for the fact that it wasn't a positive square root of 2, that we need to go to quadrant 4? So pi over 4 is in quadrant 1. How do we move that to quadrant 4? We simply rotate down and put a negative. So you want to realize that on a sine, a tangent, and a cosecant, going to quadrant 4 simply means putting a negative on the quadrant 1 answer. Okay, so let's look now at the other three with the other type of restriction. So we'll start with a cosine. We'll take a look back, remembering that our cosine is restricted from 0 to pi, and that revolves around quadrants 1 and 2. All right, so let's start with a problem that looks like cosine inverse of 1/2. And then we'll try cosine inverse of negative square root of 3 over 2. And then maybe we'll try cosine inverse of 0. Remember that we have quadrant 1 to account for the positive values, and quadrant 2 is going to account for the negative values. So 1/2 is positive, so we're going to have an angle in quadrant 1 as our answer. Negative square root of 3 over 2 is going to be negative, so we're expecting a quadrant 2 answer. 0 is neither positive or negative, which means more than likely we're going to be talking about an angle that lies not in a quadrant, but on an x or y axis. Okay, so let's go ahead and get started. Let's go to our chart and find a place where cosine is equal to 1/2. So cosine is equal to 1/2 here, and the corresponding angle would be pi over 3. Pi over 3 is in the first quadrant, and so we're done with the first example. Okay, so again, for the second one where we have the negative, we're going to pretend for a second that we don't, and we're going to find a place where cosine is equal to square root of 3 over 2. So that occurs here, and the angle is pi over 6. So this one is a little more difficult than moving into quadrant 4. It's a little more involved. We're not simply going to be able to throw a negative on the answer, because that would push that pi over 6 angle to quadrant 4, and we wanted it to go to quadrant 2. So let's look at where that angle actually lies. All right, so pi over 6 is that first angle right here. And keep in mind that it has kind of a matching twin angle on the other side. In other words, if you reflect it over, this angle is going to have the same values as the first angle, although it may have a different positive or negative sign, okay? But the triangle that the angle is based on would be the same triangle. It's going to have the same height and the same length and the same hypotenuse. So those two angles, those mirror sort of twin angles, would have the same trig values. All right, so what is that angle in quadrant 2 as we reflect it over? And so let's think about the way that we count this thing out. Here's pi over 6. Remember, this is 2 pi over 6, and 3 pi over 6 is straight up. 4 pi over 6 is here. This angle that we drew would then be 5 pi over 6. Now, a lot of times students will want to throw a negative on that. We don't want a negative on that angle. We don't want to say we're going to rotate down. We want to rotate up in a normal direction, in a positive direction. We just want to rotate till we get to that 5 pi over 6 angle. All right, and our last one, we want a place where cosine is equal to 0. We see that that's here at the bottom, and the corresponding angle would be pi over 2. Okay, so remember that our other two functions, let's see, we have cotangent is also going to have these same restrictions. So I'm going to put a couple of problems for a cotangent. And we also will have secant having those same restrictions. So we'll do a secant problem as well. So for our secant, let's say 2 on the square root of 3 over 3 is our value. We'll make that negative. Okay, so again, if you have a negative value in a cotangent, a cosine, or a secant, you're going to be in quadrant 2. So we will expect this angle to be quadrant 2. We would expect the last one to be quadrant 2. The 1 is positive, so we expect that one to come out of quadrant 1. Okay, so let's look and see what we can find. Now again, on these, you're probably going to need to flip it back to one of your base sine, cosine, or tangent values. So I'm going to do that with my cotangent. Remember that your cotangent, the reciprocal, is the tangent. So this would be the same as, I need to put my inverses here. All right, so this would be the same as the reciprocal of this, which would be 3 over the square root of 3. And we're probably going to want to rationalize that to make it look like it's supposed to look. So let's play with that just a little bit. 3 over the square root of 3, when I rationalize it, multiplying top and bottom by square root of 3. On the top, I get negative 3 times the square root of 3. On the bottom, square root of 3 times square root of 3 is 3. We see these cancel out. All right, so I'm going to adjust this right here. So what we're actually looking at is a place where tangent is equal to negative square root of 3. So let's go to our chart and look. So tangent is equal to square root of 3 at pi over 3. So our base angle in the first quadrant is going to be pi over 3. But now remember, we need to take that angle into the second quadrant. So I'm going to go ahead and draw it in the first quadrant, pi over 3. I'm going to mirror it over into the second quadrant. And again, that second angle is going to have the same trig values. It may have a different positive or negative, but it will have the same trig values as the pi over 3 angle. So what is that angle? Well, we have pi over 6, and this is 2 pi over 6, reduced as pi over 3. So 2 pi over 6, 3 pi over 6, 4 pi over 6. So this is 4 pi over 6, which reduces to 2 pi over 3. Again, the angle itself is not negative because we are rotating in a positive direction. All right, our next one, we need a place where cotangent is equal to 1. The reciprocal function would be tangent is equal to 1. So where's tangent equal to 1? Here's our 1. It happens at pi over 4. And pi over 4 is first quadrant, so there's nothing else to do for that one. All right, and let's look at our last one. So again, I'm going to need to look at a reciprocal function for secant. So we know that that reciprocal function will be cosine. And I'm going to flip this fraction over, so it's going to be 3 over 2 on the square root of 3. And we need to come off to the side somewhere and rationalize that so we get it back in the format that was going to be in our chart. So I'm going to multiply top and bottom by square root of 3. It's going to give me 3 on the square root of 3 on the top. The square root of 3 times the square root of 3, remember, is 3. Times 2 would be 6. And we can simplify 3 over 6. 3 goes into 3 once. 3 goes into 6 twice. So our actual value is negative square root of 3 over 2. So I am going to add that in right here. And then let's go to our chart and see where that happens. So where is, and again, we're going to ignore that negative for a minute. Where is cosine equal to square root of 3 over 2? That happens at pi over 6. So we know that our base angle is pi over 6, but we know that we need to transform that into the second quadrant. There's the pi over 6. Here's the mirror angle on the other side. And what is that angle? We've seen that before already to be 5 pi over 6. Again, positive angle because we're rotating in a positive direction.